things. If we have a graph, we know there is this Euler formula which says the number of vertices minus number of edges plus number of faces equals 2 for a planar graph. And let's say we have a planar graph that doesn't have, let's suppose, this will be the basis of a question here. Suppose G is planar without 3 cycles, 4 cycles. So without triangles and 4 cycles. That means that for any face in the graph, that's how I can say it. It's just an arbitrary choice of how to denote it. Or for any face in G, length of it is at least 5. There's no 3 cycles and 4 cycles. So any phase, however the graph looks, must have at least that length. So for example, this one has length 5 because if you look at it, it's 1, 2, 3, 4, 5. And we can also use, beside the Euler formula for planar graphs, which was right here in the beginning, some other things. But before we do that, let's ask a question regarding this. How can we predict the number of edges based on the number of vertices for such a graph? Well, what we can do is we can realize the added number of face lengths is going to be 2 times the number of edges, because each edge bounds to faces. And also we know that if every face has at least a length of 5, then the number of added lengths of faces must be at least 5 times the number of faces. So we have this equation right here. And all we can now do is use the Euler formula. Namely, we can say that because V minus E plus F equal 2, it implies that E minus V plus 2 equals F. And this is very useful because we can now directly plug it into the previous line's equation, which says that 2E is bigger or equal to 5 times E minus V plus 2, which gives the following. And now we can directly find the estimation relationship between number of edges, number of vertices. So let's keep take the number of edges here and put the vertices and numbers on the left side. And so that tells us that the number of edges should be always smaller or equal than 5 times number of vertices minus 10 over 3. And this is an estimation we can get from the information before. So basically the whole idea was like, let's look for some estimate of number of edges in relationship to vertices if we have a planar graph and the smallest cycle inside it as its subgraph is 5 and higher. There's no 3 cycles or 4 cycles, so all must be higher. And if that's so, we can first of all count the addition of all face lengths as 2 times the number of edges. But also because all faces are at least length 5, we know that 2 times E must be higher or equal to 2 times the number of faces. And so we could use that equation and put it into the Euler formula. And that directly yielded this inequality. So now we know that we can have that the number of edges is going to be smaller or equal to 5 times number of vertices over 3 minus 10 over 3.